Okay, here we have a pattern. This is a linear pattern. Okay, so I'm going to label this here as a linear pattern. I'm going to explain why I know this is a linear pattern here. Okay, because as I look at this pattern here, I see that to get from one number to the next, all I have to do is add 3. And then if I go here, I add 3. And then if I want to go there, again, I'm adding 3. And if I go here, I add 3, okay? So that's a linear pattern. We're going to talk today about the exponential patterns that we sometimes see. Exponential patterns are different, okay? Exponential patterns actually look like this. If I started at 1, the next number might be 3, then 9, then 27, then 81, then 300, let's see, 243, okay? And it would keep going like that. Okay, so how is that an exponential pattern? Well, it's because what's happening here with this pattern is that to get to one number to the next, I'm not adding 3. In fact, I only added 2 here. And then this next time I added 6. And then this next time I added 18. And then this next time I added, what's that, 54? So what is happening with this pattern, right? I don't even want to add that to figure out how much that is, 162. So what's going on here with this exponential pattern? Well, I'm not adding 3, I'm multiplying by 3. That I'm going to show by using this little dot. Let me write it like this. An asterisk is how we can sometimes draw multiply by 3. Okay, of course, we used to use the x when we were kids for multiplying. So if I'm multiplying by 3, right? 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. This is a whole different kind of a pattern. Let's go back up to our original linear patterns. To do a linear pattern, I always had to know where did it start. That was the first thing I had to know is where did it start and how did it, how did it move, right? We said begin and move, and we said y equals mx plus b. With this pattern here, it began at 1, so y equals, the b part is going to be 1, and it is moving up 3 each time. So I would go 3x plus 1. That's this whole pattern, and you've done it before, okay? And that is all there is to this pattern. That's all you have to do is figure out where did it begin and how did it move. What about these exponential patterns? Do you think we ought to also know where did it begin? Like where does it start? And then second of all, how does it move? Turns out you're right? So y would have to be equal to, where does it start? Well, this one also started with 1. Then how did it move? It didn't go up by 3 each time, so it's not plus 3x, right? It's not 1 plus 3x, but it's times 3. And then I would have to do the caret x, which means going up and showing an exponent of x. So it's multiplying by 3 over and over and over. And that's where it gets this name exponential from, because it's multiplying. And all of them have this form. Some number a is where it begins, times some number b, and then that number is multiplied again and again and again. Now I'm showing you this little caret to show superscript, but I want to write it out. Y equals 1 times 3 to the x. Notice I just put the exponent up here high. So if I were writing, let's say, this pattern, it would be y equals a times b to the x. That is our exponential pattern, where a is the first number in the pattern and b is the number we're going to be multiplying. We use b to talk about the base of the exponent. It is the repeated factor times 3 times 3 times 3 times 3. Okay? Now you can see these patterns whenever you look at tables. So if I were to grab a table of an exponential pattern, I'm going to try and do that here real quick. I hope I don't mess everything up, but I'm going to try to do this on my Desmos calculator real quick. So I'm going to show you, here we go. I'm going to get a screenshot. Sorry, I thought I had it ready. I don't, but I'm going to get it ready. So I go y equals, let's say, I'm going to write it as a function. The f of x equals, let's say, 2 times 3 to the x power, and I hit enter. Okay, and I'm going to get my table here. I want you to see what it looks like. Okay, 0, 1, 2, 3, 4, 5, 6. Okay, I'm going to do this. Hopefully my recording is still going, and Control V, here we go. Okay, hopefully all of that worked. This is now here. So this pattern, I might say, hey, I don't know how I can write this pattern. What I can see is that at 0, when x is 0, it starts at 2. So that tells me right here, right, that the a value must be 2. That is my a value. And then I suspect that I might be multiplying, but I'm not entirely sure. And maybe my times tables are not very good. So maybe I don't know what each of these numbers is. And what I need to do is, am I multiplying by the same amount? So the idea is, watch this. I'm going to switch colors on you now. I'll go to this color and say, let's go backwards for a minute and see if there is a common factor. You do that by putting the first number at the bottom of this table here, 1,458, divided by 486. So 1,458 divided by 486. And if that number, whatever that equals to, I think it's 3. But if it's equal to 486, the next number in this table, over 162, and you know how to test for equivalence now. You can put this in the calculator. This equal to this. And you can keep going all the way up. And if all of these fractions have that same ratio, the same missing factor, then you would say, hey, man, then b, it must be equal to 3, right? It is. I just did it that way on purpose. So now I could fill this in. This is 2. That's where it began. That's the a number. Times 3 to the x. Okay? So that is what this function would look like in a table form. Now, to show you what it looks like in a graph form, what I'm going to do is I'm going to really quickly do a screenshot, right? So the screenshot's going to look like this. Go back over here to this table. Whoa, boy. Here we go. Let's get rid of that guy. Okay, we're going to come over here. This is an image of that same function. Notice that at 0, it starts at 2, and then it goes up to 6, and then it keeps going up. And it has a curve to it, and then it flattens. And this flattened part is called the asymptote, A-S-Y-M-P-T-O-T-E. That is the asymptote. Okay, that is an overview of our exponential patterns, and I will leave it up to you to get going on some work.